Hello, student. Okay, continue the continuing the power protection system unit. This is a network for the extra high voltage to low voltage. You can see by here, by this system, if you just look by this, is extra high voltage. So extra high voltage is something around 500 kilovolt to 750 kilovolt. So transformer step it down to the high voltage, or different country, different standard. This one can be 400 kV also. So step it down to the high voltage. So the high voltage is 230 kilovolt. Then this transformer make it a step down again, which can be in Malaysia. I think you have one for 145 kV. In my country is 132 kV, so different standard, different. Then another step down transformer is available by here, which is close to the city. Or in my country, it is something between 66 to 63 kilovolt. In Malaysia, it's I'm not sure. Of course, after this one, we still have a small transformer. That transformer converts 66 to 20. So maybe in Malaysia, you reach to 20K because I know 20 kilovolt. Then inside the premises, such as university, we have a multi-level. We have a transformer close to multi-level parking, which is 20 to 11 kV. Sorry, that one is 11. Before that one, we have a transformer close to roundabout around the university, 20 kV to 11. So inside the university, 11 kV to 415 kV transformer is available close to multi-level parking. So different places. I can set such a this one. As it is far away from city, the voltage is close to extra high voltage. When we are close to the city, we drop down the voltage because of the safety and protection cases, means safety of the people. So we have the protection zone. What's the meaning of protection zone? The general philosophy for using the relay and protection system is to divide the system into separate zones. We are not going to turn off a whole Kuching because of a fault in Samarahan or because of a fault in Batukawa. We just turn off a city or a part of the city of the Samarahan in order to protect and control the what we call it, control the fault. If you turn off all the Kuching, it is not a correct zone and protective zone. So we trying our best to clarify the fault, means removing the fault, since keeping the other part of system which are healthy in the healthy condition under operation. So this is the meaning of different protection zone. So different protection zone is also considered for different devices or part of power system. In the power system, you can see we have generators, we have transformer, we have bus bars. This bus bar usually considered at the substations. Okay, then we have transmission lines, and finally we have loads. We have motors as a loads again, and blah blah blah. Okay, so for protection system, these must be different protection zones. You can see the dashes here. Even for me, if you want to be very particular, it is one protection zone here, one protection zone here, and one protection zone again here for this one, and finally for this one. Then this is applicable. The other part, the dashes before, dashes behind that one, also working. So I should say, because the generator, transformer, transmission line, bus bar, blah blah blah, all the parts of power system are quite expensive part, million ringgit. Uh, you cannot easily leave it for itself, and you cannot turn the system off because of the blackout is one of the outcome. So schedule turn off is expected for maintenance, but unexpected turn off, or what we call it, energy, missing energy, it's there will be a bad result behind that one. Okay. In the case of protection of the bus bar, this is one of the example how the bus bar is protected. The protection sends signal by this relay. What is the relay? Sorry, by this CT. Okay. What is CT? Is a current transformer. The current transformer is something that carry the safe value of current on behalf of having the full current of the system. And we have PT, which is potential transformer, is a small transformer to convert the high voltages such as 230 kilovolt to the small value, which is 110 volt. You can see. Okay. So this transformer, these transformers, this is CT, this is PT. Okay. We have another type of transformer which we call it power transformer, which you can see these are power transformer. So power transformer is something you can see at the beside the multi-level parking or inside the substation. But the other one, which I call it CT or potential transformer, these are the small in compare with that big transformer. These are very small. Okay. So in the case of protection of the bus bar, we don't use the CT here. We use the CT here. Why? In the case of any protection, in the case of protecting the bus bar, these provide the overlapping for other zone. If any fault happen, the other zone also can be helped in the case of removing the fault. So what's the meaning of that one? The meaning of that one introduce another part of power system protection, which is called primary and backup protection. As the last time I mentioned, assume this is transmission line. We have different zones. They have different CT circuit breaker. Okay, so this circuit breaker need a CT. So this CT sends signal here, this CT sends signal for here, this CT sends signal for here, and blah blah blah. This is your home, and another MCB by here, MCB. Okay. If a fault happen at this area, the primary relay, the primary protection is this one. The primary protection is this one, must operate, which is the closest one to the fault point. And if this one cannot detect the fault, the backup is just after adjacent relay, just after the closest relay to the fault point, which is this is backup relay, backup relay at this point. Okay, so the backup relay must operate. I think I mentioned in the first session, backup relay must operate in the what we call it, by a discrimination between primary. This discrimination is called DT, discrimination time, usually considered as 0.4, but in the test or in the coordination of the relay, usually it's given to you 0.4 second. So if this one assumed to be operate instantaneously by 0.1, this one will operate in 0.5, which is 0.1 plus 0.4 to protect the power system. So the backup protection are very important part of power system. But don't forget, the backup protection must be coordinated with the main one. Otherwise, a blackout or a big blackout or an unwanted operation of the relay are expected in the system. So I explained what's the meaning of primary, what's the meaning of backup protection. Directional protection. Directional protection is in the case of new life, new life of power system. Before that, we have power plant. This is power plant far away from cities. Then we have, of course, transformer, transmission line, and then we have load. So the only way of the power flow is from this way, coming in until the load, correct? But these days, again, assume we have at the mid, we have another city. This is Kuching, this is Miri, or this is Bintulu, okay? So the power plant send energy first to Bintulu, then to Kuching, blah, 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 okay? In the case of the new power system, which we install the PVs, wind farm, wave energy, whatever, renewable energy considered, okay? If we can generate energy by these two, this energy can return back to Bintulu, correct? So the direction is already changed. The one-way road become double-sided. So it is very important for the relaying system to know how the flow is. In the case of the fault current, okay, if there is any return current, means the current return back, or means assume we have the relay by this way and highlighted this arrow. This arrow means this relay only operate for the fault current on that way. On behalf, we have another type of relay, the same as this one, which will operate only on this way. So if there is a fault by this point, the current, let me change the color to blue, okay? The fault current will coming from this way to the fault point, and from this one coming to this point. So this relay will operate because of these two, and this relay will operate because of the main power plant. So the direction of current will be detected by some relays. Example number one, check the correction operation of the protective system. Assume we have fault. Okay, here we have four scenarios. One by one, I'm going to explain and find out how and which relay must operate. Okay, fault number one, assume only fault number one executed in the system and the other faults are not here, okay? Fault number one, the primary relay must operate are number 4 and number 3, correct? In the case, okay, in the case, let me change the color, assume is number 4 and number 3, correct? Okay, in the case that the primary protection of number 3 missed, which relay must operate? We should find the source. So this source send the energy to this point, correct? So relay 1 is the backup for relay 3. The only one? No. Just look, we have another source at here can send the energy to this point, correct? So number 1 and number 2 are considered as backup. So are they only? Yes, there is no other relay can work as a backup for number 3. What about number 4? Okay, if number 4 fail, which relay must operate? You can see we have a generation system by here which can send the current to fault point. So number 5 is one of the eligible one, correct? Then what about number 6? Number 6 is a load. This one is considered as a sign of load. So the load cannot send any energy back to our system. So number 6 is just leave. What about this way? So this way, from this way we can having energy, but is there any source? This is load, this is load. Oh, this is the source. So from this way, the energy coming, passing 8, then 7, then coming here. Yes, it can. So which relay must operate? 7? No, come on, 7, look at the direction. It will operate on the other way. So for that one, number 8 must operate. So if number 4 fail, number 5 and number 8 are considered as a backup of the fault protecting relay. Okay, let's consider the next case, which is number 6. Okay, for number 6, the primary relay, of course, is number 6, means fault at point 2. Of course, this is primary. Which one is the backup? Okay, if number 6 fail, if it's not working, we have a source of energy, send current to this point. So number 5 is the first backup. From this way, from this way also, we have two sources, 1, correct, and 1. So these two added to each other and send current to the fault point. So we should expect number 3 as a backup for this side. What about the other one? The other one is this, which send a current to the fault point. Again, number 8 must be considered as a backup for fault at point 2. Then we have a fault by 3. So primary is 10, correct? So backup, no need to highlight the primary. So let me find out the backup. So the current from this way comes in. This is the first. So number 9, the first backup. Then from this source of energy, we can send. So number 7 is because it's aligned with the what we call it, the fault current. Number 7 is the second. What about this one? Again, this one coming from this way, going down. Number 7 will find it. This one also in the same way. Number 7 will catch it. Okay. So our expectation is number 7 and number 9, operation only. And the last one is number 4. Okay. For this fault, should be more or less the same, correct? The operation the same, more or less. So 11 is the main, and the backup is 9, and then 7. Why not? So you can go through this one and review and the explanation, which one is the main and which one is the backup. So the problem or the synthesis of the power system. The power system must maintain in the normal condition, the same as the human health must be always in the normal condition. Maybe your pressure increase, maybe your temperature increase, okay, as a fever I talking, but must be maintained in the normal condition. So what is the limitation for the voltage? The voltage limitation is plus minus 6. So this one can up to 10, okay, up to 10%, okay, in the case. But the frequency is plus minus 2%. Plus minus 2%. I think is a lot one. 50 plus minus 0.02. I think it should be 0.0. It is 0.02% or 2%, 6%. So this is the real value here for the voltage. Okay, for the voltage is whatever the voltage is, assume is 415 or 230 plus minus 10%, 10% of this value. So it is there. Okay, the small disturbances which consider as a variation in the transformer or generator loads. Sometimes, for example, we have the morning and night at the city, so the generation is totally different, morning, noon, and afternoon. So this is considered as a small changes in power system, but we have several disturbances in the power system. So these are the most important. Severe disturbances are usually coming from lightning and switching. Let's consider and plus fault. Don't forget the faults. The real fault in power system. Okay.